we have a problem number 4 on handout 8.4. So you have a ship travels from point A to point B directly north. This is a little bit tilted, but it's supposed to be straight up, okay? To point B, directly north. And then it's gonna travel to point C due east. There you go. Okay, that's the only information given, but you know that this is a 90-degree angle because it first went up directly north and then went due east. So that makes this a 90-degree angle. Okay, the next piece of information that is given is the magnitude of the vector from A to C, which is 134. Okay, so you have, let's call this one vector U, and we are going to resource to the formulas that we have on the book pages, which is pages, I believe it was 793 to page 811, something like that. Okay, and there's the formula where it says the magnitude of a vector is given by the square root of the sum of the square of its components, meaning the components to be the vertical component and the horizontal component. So there you have your formula for the magnitude of the vector. And then we have some other formula. It says each one of the components is equals to the magnitude of the vector times cosine of the angle theta, which is the angle that will be right here. This angle is not given, unfortunately. And then the other component will be the component B. It's going to be the magnitude of the same vector, which is in this case is vector U, times sine of the angle theta. Okay, so that will be the angle right here. Okay, so since there's no other piece of information given, we're gonna have to assume in this case that this is an isosceles triangle. Okay, you do have the 90-degree angle, but you don't have these angles. Okay, because of the way the problem is set up, it's safe to assume that this is an isosceles triangle that giving you the two base angles congruent. Okay, that means that each of these angles will be 45 degrees. Okay, so we're gonna now, the question of the problem is, okay, what's component A and component B? Or in other words, it's asking you, what is the magnitude of the vector due east and the magnitude of the vector due directly north? Those are the two questions of this problem is asking. Okay, so component A, that will be component A and B. Component A equals the magnitude of the vector U, which is this one, which is 134, that's the magnitude given, times cosine of the angle theta, but we don't have theta, but it's safe to assume in this problem that it is an isosceles triangle, so that's going to make this angle and that angle congruent, and that's going to be 45 each, 45 degree angles, 45 degrees. And the magnitude of the vector B, or the other component, is equals to the magnitude of the vector U, which is 134, times cosine of the angle theta, which is that one, which is 45 degrees. Okay, we're almost done. That's 45 degrees. What's sine? Square root of 2 over 2. What's cosine of 45 degrees? Square root of 2 over 2. See, the hand is always the hand trick for the trig function values is very useful. So in the whole pre-calculus and also in the SAT test and in all the testing that you need to do, because they don't let you use like formula charts, or it's just, and you want exact measurements. The calculator gives you measurements that are not good. Okay, so what we're gonna do is B equals 134 times square root of 2 over 2. A equals 134 times square root of 2 over 2. Therefore, B equals 134 divided by 2, 67 square root of 2. A equals 67 square root of 2. And that concludes problem number 4 in handout 8.4.